Okay, so workbook page, what was it, 79 and 80? Okay, so let's start on page 79. So first off, on page 79, the very first thing that you were asked to do were find the multiples of a specific number. So this should have been probably the easiest, quickest section of the entire homework from last night. So you had to take the number that was given to you, and you just simply had to list the first 8 multiples of that number. Okay, so if you notice, everybody look at problem number 1, where they actually give you the number that you're playing with, and that number was 2. So your job was to list the first 8 multiples of that number. So all you had to do was count by 2s, okay? And that would give you the first 8 multiples. So you would have 2, 4, 6, 8, 10, 12, 14, and 16, okay? So that's your 8 numbers that I should see as an answer for question number 1. But did any of you all realize that the last number matched what I would get if I multiplied my number by 8, since I needed 8 of them?
Yes.
Okay, if you did, good job, good observation. That worked for every one of them. So for example, on number 2 then, for number 2, the number that you played with was 3. You had to list the first 8 multiples for 3. So what's the first one going to be? Everybody? 3. What's the last one going to be? 24. Because if I multiply that 3 that I started with times 8 of them, the last one's going to be 24. So all the ones in between would just be 6, 9, 12, 15, 18, and 21. Okay? This section, probably a pretty simple section. Any questions on how to simply find the multiple of a number? We all good on that? All right, let's move on to the next section. And I know some of you are curious if you got all these answers right. We're not going to go through every single one of them. I don't have time. This class only lasts for another 20 minutes. So that means I have to kind of eliminate doing some things in the classroom where we won't have time to complete stuff. So let's move to the next section. The next section is where you had to list the first 4 common multiples. So raise your hand if this section is where it took you a long time.
No, I didn't take it.
Okay, some of you yes. All right, if this section took you a long time, maybe you didn't identify the shortcut.
I did.
Okay, so let's look at problem number 7. Problem number 7 started with 2 numbers, and those 2 numbers were 7 and 2. So the first thing that you should be doing when you are trying to list common multiples of 2 numbers, or maybe even 3 numbers, is you should be trying to ask yourself, are those numbers prime or composite? In this situation, what kind of a number is 7? Everybody? Prime. What kind of a number is 2? Prime. So yesterday in class, we learned a little shortcut that helps us to know when both of them are prime, what's the quick trick that we can do? Dominic?
Multiplying them together.
Multiply these 2 guys together.
That's what I did.
And when you do, the number that you get is the smallest number they have in common, or the LCM, the least common multiple. Okay? So that's the first one. But some of you are going, but Miss Malone, it says that we have to list the first 4. Well, that's not a problem. Because now, if the first one is 14, then all of the other ones are just going to be add 14 more. So what would be 14 more from 14, everybody?
28.
That's your next common multiple. What if I added 14 to 28? What would I have?
42.
That's my next common multiple. What if I added 14 to 42?
56.
That's my last common multiple. Did I really have to list all of the multiples for 2? and all of the multiples for 7 and keep going until I was able to circle 4 of them that they had in common? Do I really have to do all of that? No. That's when things start taking a lot of time. Eyes this way. That's when things start taking a long time. So if we start looking for shortcuts, things that we can do to help us get to our answer quicker, it's going to be a really big lifesaver. Okay? So for question number 7, this right here is the answer that I was searching for. Those should be the first 4 numbers. Somebody's cell phone must be going off. Is that a cell phone? Or maybe it's a laptop. Check your laptops if somebody had a website open and make sure that something just didn't start playing.
I think I heard it.
Okay. Well, if it pops up again, we all have to kind of check because obviously something electronic is going off on somebody's device. All right, let's look at problem number 8, okay? So does this make sense to everybody?
Yeah.
All right. Again, these are little shortcuts. Now, let's look at problem number 8. So on problem number 8, this time I have numbers 3 and 6. So let's ask ourselves, 3 and 6. Are both of those prime?
No.
No. So since they're not both prime, can we do the shortcut that we did up above? No, we cannot. The only time that shortcut works is if every single number is prime. And down here in this little green section, one of these guys is composite. Okay, but there is another shortcut though.
Yep, I think there is. I see it.
So here's what you gotta ask yourself. This guy is prime, that guy is composite. Oh my.
Someone else is casting.
It is. So I thought it
Someone
is.
is correct.
Miss Freer actually did not social studies.
Okay. That's okay, it's okay, you all relax, sorry. So, here's what you have to ask yourself. Will this prime number fit into that composite number perfectly? Yes or no?
Yes.
Yes. Since it does fit in there perfectly, this number becomes your least common multiple. That's the smallest number they have in common. So again, that's another quick trick. They both aren't composite, or they both aren't prime. Now some of you are going, but you could multiply those together and get a multiple. Well, yeah, you could, but you're not getting the smallest one that they have in common. And the smallest one is how we know to then just keep adding that number to get the rest. So if the first one's 6, what would 6 more be? 12. So there's your second one. What would 6 more from that be?
8.
So there's your third one. What would 6 more from that be?
24.
There's your first 4 common multiples. Okay? Questions on this? What?
What if the number that was prime what if it couldn't fit?
Beautiful question. Okay, I love it. So she wants to know, well, what happens if it doesn't fit either one of those rules? Okay? So she says, what happens if you have, let's look at one of our examples from your homework last night. Like, all right, everybody look at problem number 12. All right, so problem number 12, babe. 5 was one of the numbers that they gave. 8 was the other. So Lydia wants to know, well, since 5 is prime, you taught us a trick. The trick is to see, will 5 fit into this number perfectly? Will it? No. So since it won't, then that means this one can't be the first number that they have in common. So then we can go back to that other trick that we used where we can multiply them together. And what do we get? 40. So there's your smallest number that they have in common. So now to get the next one, just add 40 more, which would be 80.
I kind of got myself. I didn't put
40 more would be, and then 40 more,
160.
there's your first 4 common multiples. Do you think if you would have known these things last night, it would have saved you a lot of time?
Yes.
Probably would have. But would you have learned it as well as you probably know it right now? Maybe not, okay? The only other situation is, well, what happens when neither one of them are prime? And that would be in an example of like number 9. So number 9 has a 6,
No, 3.
but then also has an 8.
That's 9 on the other side. Yeah, there's 2 9s.
Oh, my bad. Okay. It's supposed to really be 10, okay? Because the book has a typo. So on question number 10, they have a 6 and an 8. So this doesn't fit any of the rules. There's no prime numbers at all. They're both composite. So how am I supposed to find the smallest one that they have in common? Well, now you may have to go to the old way. List the multiples of 6, list the multiples of 8, until you can find the smallest one that they have in common. And when you do that, what would you have gotten for 6 and 8? Addison?
18.
18?
Yeah.
Is 8 times 2 anything 18?
Wait, hold on. This is number 24.
24, very good. So 24 should be the first number that 6 and 8 actually have in common. So now to know the leftover ones, what are we going to do, Hallie? We're just going to add 24 to each new number we get. So the next one would be 48. The next one would be 72. The next one would be
92.
There's your first 4 numbers that they have in common. Okay, there's your little tricks to kind of help you. So when you get to these things, can you do it the other way?
Yeah.
Sure. I mean, you can do it the long way, like listing all of those multiples out for both numbers and then circling the guys that match. Sure, that's one way of going about finding the answer. It's just going to take you a long time when you do that. So I'm trying to offer you new ways to do this stuff so that when we take tests and you only have 40 minutes to take this test, you're able to finish in 40 minutes because you use these quick tricks to help you to get the answer you're searching for. What?
So like we do it with like 3 numbers.
Okay, so she wants to know what it looks like for 3 numbers. All right, so for example, let's look at problem number 16, okay? So for problem number 16, there is a 2, a 3, and a 5. So let's see, will this fit any of our quick tricks? Let's ask ourselves, are all these numbers prime? Yes. And what do we know is the quick trick for prime numbers? Multiply them all together. So 3 times 2 is? 6 times 5 is? That's your first number they have in common. And then you would just continue to add 30 to find those other numbers. Okay? Now, if they're not, honey, if they're not all prime, then you kind of have to do a little more work to figure out the one that starts it. All right, how do you feel with that? Okay, what, Max?
Oh, I knew this last night, and it didn't take me like any time.
Excellent. So you kind of caught on to that earlier on before today. Beautiful. All right, turn to page or look on page 80 now. Okay. So page 80 is where you had to find the least common multiple. So here again, use these little quick tricks for help. If they're both prime, multiplying together, boom, you know the smallest number that they have in common. If they're not both prime and only one of them is, kind of like this little example that we did up above, this green number, ask yourself if that prime number will fit into that composite number. If it does, then that composite number is your least common multiple. If neither of them are prime, kind of like this little blue example here, like for the red example, then we have to kind of figure out, list out the multiples of 6, list the multiples of 8, find the first one that they have in common. And so that's what you did for section on the back, least common multiple. So, and then we moved in, so questions on that, are you all pretty good there?
Yeah.
Then we moved into least common denominators. Some of you guys are not paying attention, and so when I get emails that say you don't understand what we did in math, you're not paying attention. Okay, so like you have to kind of engage in class if you want to be able to understand what we're doing. So please give me the attention or else you're going to be lost. Least common denominator. This is important. You're going to be using this stuff for adding and subtracting fractions, which is the next 2 chapters we're going to do. So very important that you understand how to find the least common denominator. Remember, it's the exact same thing as least common multiple. The only difference is the number is in the denominator. It's in a fraction. Starts out as a fraction. What?
I was gonna answer your question.
Wait just a second, okay? So if we look at problem number 10, we have 2 fractions. We're on the back. Everybody's looking on the back, right? The first fraction is 2 over 8. The fraction next to it is 3 over 12. What 2 numbers are in the denominator position, Addison?
The 2 numbers are 8 and 12.
8 and 12. So we have to figure out between 8 and 12, what's the smallest number that they have in common. So use your tricks. Are they both prime? No. So I can't use that quick trick. Is one of them prime?
No.
So I can't use that quick trick. Are they both composites?
Yes.
Yes. So now I have to do a little work and figure it out. What's the least common denominator for 8 and 12, everybody? 24. Okay. So this is how we went about solving that stuff. How are you feeling with that? Okay. Then you moved into the next one where it said, here's some examples. Which ones would give you a common denominator of 45? You should have chose the first example and the last one. The ones in the middle don't work. Okay.
Why doesn't the second one work?
The second one doesn't work? You tell me. Remember, there's a 3 and a 15. That fits this trick right up here.
15.
That fits this trick. 3 would fit into 15, so what would be the first number they have in common? 15. Okay. All right, let's look at the word problem. So this word problem, when I show you what the answer is, you're going to go, oh, that makes more sense now. I think the word problem just sounded confusing.
Yes.
And so therefore, it sounded like I don't know what to do.
Yes.
But if it was put in different words, I think you probably would have understood what it was asking. So here's what it was saying, okay? It says, are common multiples of 2 numbers always multiples of the smallest number they have in common?
Yes.
Here's what it means. So let's look at this example. Here's our 2 whole numbers, 6 and 8. This question wants to know, are all of the numbers in this list a multiple of the smallest number that they have in common? Yes. That's what that question was asking. So when it asks, will that always be the case? Your answer should have been yes. Anytime you find the smallest number that 2 numbers have in common, the rest of them will be a multiple of that number. Just like it was here, just like these are all multiples of 40, just like these are all multiples of 6. It works every time. That's what that question was asking, okay? And then the last one, which basically says here's a pie. The pie's been cut into 4 slices. If I wanted to keep cutting this pie into equal slices, how would I have to go about doing this, Brody?
You would cut it into 8 slices.
I would have to keep cutting it in multiples of 4, right? So I could cut it in 8, or else I could cut it in 12, or I could cut it in 16. Could you continue to just chop it into groups of multiples of 4?
They just be
Yeah.
teeny tiny.
until the point where you have no slices left over, right? Like it'd just be like such tiny little slivers of stuff.
That you wouldn't
You wouldn't even know what you had anymore. But as long as you cut it into a multiple of 4, they'll stay even all the time. What?
This has nothing to do with math, but do we have a relationship?
Study guide? No, we'll study tomorrow for it. We will review tomorrow and then you'll be ready on Thursday. Okay? All right, so how do you feel now with that lesson? All right, so don't put things away. Remember, that was your workbooks. You can put the workbook aside. But I do need you now to look in your notebook. Because even though in this class period always dings us a little bit with math, because it's a short period, and lunch got extended 5 extra minutes, and then we end up using the bathroom, which always takes about 7 minutes. So that takes away about 12 to 15 minutes that really I would have gotten to have taught you. So we are going to work for about 5 more minutes, because Ms. Priest's readers are also going to work for about 5 more minutes in their classes. And we're going to try to look at what this next lesson is, okay? So I need in your notebook for you to title your notes today. Do not worry about having to write all this. You're not going to. All you are going to write is the stuff that you see at the top in blue, which is the title of this lesson, Lesson 5-5. This is a problem-solving lesson, which means we're going to see word problems. But in order to solve these word problems, we are going to make tables. And what a table is, you think of a table as in like a table that dinner is served on. In math, a table is like a graph. It gives you a place to look at that has all the information on it. Okay? So again, you are not writing this stuff in black. You're simply putting the title, which is, we're going to learn how to solve problems using tables, graphing tables. Okay? If you really want their fancy name, they're called XY tables. So X is a variable in math. Y, the letter Y, is a variable in math. So when you put those two together, it's a graph that X represents some things on the graph and Y represents something else. So these are X, Y graphs. So now, how are you going to go about solving this stuff? You do need this information in red. So take a minute and put that into your notes. Now, some of you already do this. So again, if you don't need it in your notes, I guess you don't have to write it. But for those of you that struggle a little bit with word problems, these might help you to kind of know the major things that you have to do when you come across word problems. What? I'm not hearing you. What? You could. They just don't call them that in the math world. They call them X, Y. But you can call them whatever letters you want. You want to call it an A, F, table? You call it that. But that's just not what their title is. Okay?
table.
Kind of like, they chose to call McDonald's, not, the land of Big Macs. Okay? So, but you could call it that if you wanted to. All right. So to solve word problems, the very first thing that you should teach your brain to always do is identify the question that you are trying to find the answer to. And most of the time, almost always, the question will be located in the last sentence of the word problem. Okay? Step number 2, once you know the question that you have to answer, then you got to go back into the word problem and you got to find that important information. Which again, this is something that a lot of you already do. Step 3 is the hard part. That's the part where most of you come asking me what to do. You know the question, you found the important information, but now you just don't know what kind of math you're supposed to do. Okay?
I don't know.
So obviously, Obviously, that's the part that causes some of us the biggest struggle, is what kind of math are you gonna use? So that means, am I gonna add, subtract, multiply, or divide? All right, now here's the thing. So Miss Frieders is out there, and unfortunately, you all didn't get to the place where everybody else got to. So I cannot give you the assignment for today. Because you won't necessarily understand how to do it. So your assignment is now going to be pushed till tomorrow, but there's a small chance you may have to double up tomorrow, okay? Because I got to get you